Good evening, folks. This is Mike coming back at you with a continuation from our previous video. In the previous video, we introduced the concept of the determinant. We found out how do we find the determinant of 2 by 2 and 3 by 3 matrices, and then we learned the important condition we need for an n by n matrix to be invertible, aka to have an inverse. In this video, we're going to wrap up this section and this chapter as well, and we're going to see how we can use these determinants to solve systems of linear equations. And we're going to do that with the use of Kramers Rule. So this is Kramers Rule for two equations in two variables. Suppose you have a system of two linear equations in two variables. You have these constants, a1, a2, b1, and b2. Those are the coefficients on your variables x and y. And then you have the numbers that these things are equal to. Call them c1 and c2. And we're going to find a few determinants of some 2 by 2 matrices here. We're going to find D, which is the determinant of the matrix with the elements a1, b1, a2, b2. We have D sub x, which is the determinant of the 2 by 2 matrix C1, B1, C2, B2. So we took our A values and they got replaced by our C values. So that's D sub x. And then we have D sub y, which is the determinant of the 2 by 2 matrix with entries A1, C1, A2, C2. So now we had the b's, which were the coefficients of our y's, and those were replaced by c's. And that's our dy. So you can think of it sort of as dx. The x coefficients are being replaced with the c's. Dy, the y coefficients, the b values, are being replaced by the c's. Then, as long as d here is not equal to 0, we have that x is going to be d sub x over d, and y is going to be d sub y over d. So we're going to solve a couple sample problems using Kramers rule here. First one, 5x minus 2y equals 2, and 3x minus 3y is equal to a positive 1. We need to find some determinants of some matrices. D is again the 2 by 2, or the determinant of the 2 by 2 matrix with coefficients being the numbers on the x's and y's. So 5, negative 2, 3, and negative 3. It's pretty straightforward to calculate this determinant. 5 times negative 3, negative 15, minus 3 times negative 2, negative 6, and that gives me negative 9. So good. D is not equal to 0, so we know that we have and will get something for x and y here. Let's get D sub x now. It's the 2 by 2 matrix. Again, D sub x, I take those numbers that those things are equal to, and that replaces my a's. So here, these two entries in the second column will still be negative 2 and negative 3, but now instead of 5 and 3, we're going to have 2 and 1. So 2 and 1 there. And this determinant, 2 times negative 3 minus negative 2 times 1, that is equal to a negative 4. We need D sub y. It's the determinant of the 2 by 2 matrix. Now here, the coefficients on the x's remain, but the coefficients on the y's get replaced with our c values. So here it's going to be 5 and 3 in the first column, And then instead of -2, -3, our second column will be 2 and then 1. And this determinant is going to be 5 times 1, or 5, minus 2 times 3, or 6, and that is -1. So we found these three determinants. We just now need to use these basic formulas here. X is d sub x over d. So -4 over -9, or a positive 4/9. Y is equal to dy over d, dy of -1 divided by -9, or a positive 1/9. So these are indeed our solutions to this system of two linear equations in two variables. You can plug these things back in and you can check that they are indeed valid answers. All right, I'm going to challenge you guys. Try this one on your own. Try to solve this system of two linear equations in two variables by using Kramers rule. So press pause, work it through. Once you think you have the answers, press play, and we'll see if you were correct. Okay, so let's see if you came up with the correct answers here. First of all, our matrix D, the elements are 1, -3, 5, and -9, just the coefficients on the x's and y's. The determinant of that 2 by 2 matrix is a positive 6. D sub x, we take this matrix here and we replace the first column with our values of 4 and 3, and then we take the determinant of that 2 by 2 matrix, and that is -36 minus a -9, or +9, and that gives me -27. D sub y, I take this matrix, I replace the second column with my numbers of 4 and 3 here, and then take the determinant of that resulting 2 by 2 matrix. 3 minus 20 gives us -17. So our x value, d sub x over d, -27 over 6, or that's the same thing as -9/2. And then y is d sub y over d, -17/6. So hopefully you came up with -9/2 for x and -17/6 for y. If you did, well done. If you didn't, try to go back through the problem and see where things went off. So that's Kramers rule for a system of two linear equations in two variables. It's very similar. We're doing the same kind of thing for a system of three linear equations in three variables. Unfortunately, the determinants we have to find are not as nice, and there's one more that we have to find. So here's Kramers rule for three equations in three variables. You have a system like this. A1, A2, A3 are your x coefficients. B1 through B3 are y coefficients. C1 through C3 are z coefficients. And then those things are equal to numbers D1, D2, and D3. We're going to have four matrices this time. We're going to have D for determinants, actually, I should say. Capital D, the determinant of the 3 by 3 matrix formed by the coefficients on our variables. D sub x is determinant of the 3 by 3 matrix formed by having our D column replace our A column. D is replacing the x coefficients. D sub y, determinant of 3 by 3 matrix, you get as a result of taking D and having taking capital D here and replacing these little d values with the b values with that second column. And then capital D sub z, determinant of 3 by 3 matrix obtained as a result of taking capital D and replacing the little d's with the c's. So unfortunately, there's a lot of 3 by 3 matrix determinant finding that's going on here, but it's still at its core the same kind of thing as what we did with 2 by 2. So once you've found all those things, as long as capital D is not equal to 0, then x is d sub x over d, y is d sub y over d, and z is d sub z over d sub over d. So very similar formulas. They are the same. It's just kicked up a notch because we have one more equation and one more variable involved in here. So we just have some, unfortunately, slightly tedious calculations that we have to do here. So we're going to do a sample here where we use Kramers Rule. And in fact, let's actually use our calculators here because for 2 by 2s, it's not that bad. You find a few quick determinants of some 2 by 2 matrices. That's not that hard. It's a lot nastier when we're doing 3 by 3s. So let's just write out what each of our 4 matrices are going to be. Then we'll plug them in here, and we are going to do, we're going to let the calculator do a lot of math for us here. So let's at least write out our 4 things here that we need. D, determinant of matrix of coefficients of variables. 1, 1, 1, negative 3, 4, negative 1, 5, negative 2, positive 2. D sub x. Again, we're taking D, and the column of the x coefficients is being replaced by these numbers here. So 4, 3, negative 2, 1, 4, negative 2, 1, negative 1, 2. D sub y, taking the thing that we have here for D, replacing the second column, the y coefficient column, with these numbers here. So 1, negative 3, 5, 4, 3, negative 2, 1, negative 1, 2. And then d sub z, taking this guy here, the column of z coefficients is being replaced by these 3 numbers here, 4, 3, and negative 2. So if that was cut off earlier on in the video, I'm sorry. Again, d sub x, this column replaced the x coefficients column. And for dy, this column here replaced the y coefficients column, 1, 4, negative 2. Okay, so at this point, we are just going to take each of these things. We're going to plug them into our graphing calculator, and we're going to see what values we came up with. So I'll let you do that on your own, figure out what the determinants of each of these 3 by 3 matrices is going to be. So press pause. Once you have them, press play, and let's see if you came up with the correct determinants. Okay, so let's see what determinants you came up with. Hopefully you found that capital D was negative 7, capital D sub x was 22, capital D sub y is negative 1, and capital D sub z was negative 109. So using these 3 formulas right here, I'm going to figure out what x, y, and z are. X equals d sub x over d, negative 22 over 7. Y equals d sub y over d, 1 over 7. And z equals d sub z over d, negative 109 over negative 7, or a positive 109 over 7. So there we go, guys. Yes, having to do a system of 3 linear equations in 3 variables using Kramers rule, it is kind of long, it is kind of tedious. This is not likely the kind of problem where I would have you do these by hand. You know, this is something you could use your calculators to at least make it a little less ugly. But that concludes our video and the chapter on matrices, inverse matrices, determinants, all that good stuff. If you have any questions or comments, guys, again, please be sure to reach out to me. Text, email, phone calls, new Zoom meeting, whatever you have to do. Until the next video, take it easy, guys.